everyone. In this video, we will solve AP Chemistry worksheet regarding molecular geometry concept. Let us start. The molecule is GeF4. We want to draw its Lewis dot structure. We have to know that germanium belongs to group 4, so 4 electrons in the valency. Fluorine belongs to group 7, so 7 electrons in the valency. Germanium is the central atom, so which has the lowest electronegativity and the lowest subscript in between these two atoms. So surrounded by 4 fluorine, sorry. And as we learned from the Vesper, it makes here, it's a tetrahedral structure. We will answer this now. The valence electron is 4 plus 4 by 7, 28 and 4 sum up to 32 electrons. If you count here the electrons, you will find them 32 electrons. Electron pair geometry, as you can see here, we have around germanium 4 electron clouds, which means it is tetrahedral. No lone pair, all of them they are bond, which makes the molecular geometry also tetrahedral. Now let us see if it's polar or non-polar. We can check polar or non-polar either of two ways. Either you check the pooling table, number of electronegativities, or we can use the concept here, electronegativity increase across the period and decreases down the group, which makes that fluorine is has higher electronegativity than germanium, which is plus. So the arrow goes from plus to negative. These two have this resultant, they cancel each other, which makes it non-polar. In the previous video, we spoke about hybridization. We said that the atom that is surrounded by 4 regions of electron cloud, it has sp3 hybridization. Okay, let us take another example. AsI3. As belongs to group 5, so 5 electrons in the valency, and iodine belongs to group 7, so 7 electrons in the valency. The total number of valence electrons, 5 plus 3 times 7, sum up to 26 electrons. So we have As surrounded by 3 iodine. Okay, each iodine has 6 electrons multiplied by 3, which is 18, 19, 20, 21, 22, 23, 24, 25, 26. So the electron pair geometry, we have 3 bonds. We have 4 regions of electrons, bonding and non-bonding, which is tetrahedral. But here the presence of lone pair make the geometry distorted tetrahedral, which is trigonal pyramidal. So it will be trigonal pyramidal. Now polar or non-polar, we know that iodine is more electronegative than arsenic. So if I want to draw the arrows, there is net dipole moment, so it is polar. Since arsenic surrounded by 4 electron clouds, so the hybridization sp3 hybridization. Okay, there are so many examples. I will select from this worksheet. So I can solve, for example, H2Se. Let me count the valence electron. Selenium belongs to group 6. 1, 2, 3, 4, 5, 6. Hydrogen belongs to group 1. So it's 2 plus 6, sum up to 8. So we have selenium and 2 hydrogen around it, and these 2 lone pairs. selenium reaches octet, which is feeling 8 around it. Hydrogen feels the duet, feeling 2 electrons around it. Now the electron pair geometry. As you see, we have 1, 2, 3, 4 between bonded and non-bonded. So we have 4, so it's tetrahedral. But the molecular geometry is distorted tetrahedral because we have 2 lone pairs. And when we have 2 lone pairs, the shape turns to be bent. Is it polar or non-polar? Selenium is more polar than hydrogen. The arrows drawn like this. The resultant of these 2 arrows upward, nothing to cancel it. So the net dipole moment is not 0, so it is polar. Surrounded selenium by 4 electron clouds, so the type of hybridization, sp3 hybridization. Let us see radon chloride. Okay, radon belongs to group 8, so 1, 2, 3, 4, 5, 6, 7, 8. Chlorine belongs to group 7, 1, 2, 3, 4, 5, 6, 7. Radon surrounded by 2 chlorine. Let us see. Radon surrounded by 2 chlorine, and here, okay, let us count the valence electron. 8 plus 2 times 7, which is 14 plus 8, sum up to 22 electrons. Okay, 2 chlorine each with 6 electrons, so it means that 6 by 2, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So we have here 3 lone pair around the radon. Let me redraw it. 3 lone pair around the radon. So Rn, Cl, Cl, and 3 lone pairs around the radon. Okay, let us see the electron pair geometry between bonded and non-bonded. We have 1, 2, 3, 4, 5. 5, and there is 3 lone pair. It means that we have the shape which is linear shape. So linear shape for molecular geometry, and trigonal bipyramidal for as if it has 5 bonds. So trigonal bipyramidal, this is for the electron. Trigonal bipyramidal, but instead of 5 bonds we have 3 electrons, so it will 3 electrons lone pair, so it will be distorted one and it will be linear. Is it polar? Non-polar. Chlorine is more electronegative than radon, so no net dipole moment, so it's non-polar. Now what about hybridization? We have 5 electron clouds around it, so it is dsp3 hybridization. dsp3 hybridization. Okay, let me take another example. For example, TeF5, let us solve it. Tellurium belongs to group 6, so 6 electrons in the valency. Fluorine, 7 electrons in the valency. Total valence electrons, 6 plus 5 times 7, and minus 1, it means electron is gained. So 7 by 5, 35, plus 6, 31 plus 1, sum up to 32 electron. Let us draw it. So we have tellurium and 5 fluorine surrounding it. And here minus, okay. Each fluorine has 3 lone pairs. of electron. Okay, if I want to count the electrons, each fluorine carries 6 electrons times 5, so 30, 31. Each one carries 30. Okay, sorry, here there is mistake in the counting. 35 plus 6, it's 41 plus 1, 42 electron. We will continue. So 6 times 5, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So there should be here also lone pair. Now what about the electron geometry? When we have 6 around, so this electron belongs to this tellurium. So when we have 6 bonds, 1, 2, 3, 4, 5, 6, so it is octahedral. Now what about the molecular geometry? Instead, not all of them they are bonded. One of them is lone pair. So when one of them is lone pair, it will have the shape square pyramidal. So this will be square pyramidal. Now, is it polar or non-polar? If we have to see the polarity, fluorine is more electronegative, so I will redraw it in a more obvious way such that we can see the polarity. I will draw it here, so it will be like this: tellurium, lone pair, fluorine, and fluorine. This is the shape of square pyramidal. Fluorine, fluorine, and fluorine. Let us check its polarity. Fluorine is more electronegative. It's the most electronegative element. Okay, drawing the arrows from positive to negative, positive to negative, positive to negative, positive to negative. This one cancelled with this one, and these two, they have this resultant that cancel with this one, which makes it non-polar. Now, what about hybridization? Tellurium, it's surrounded by 6 electron cloud, 1, 2, 3, 4, 5, 6. So it has D2sp3 hybridization. Let us see BeI2. Beryllium belongs to group 2, so it has 2 electrons in the valency. Iodine belongs to group 7, so 7 electrons in the valency. Let us count the total valence electron. 2 plus 2 times 7, which is 16 electron. So we have beryllium and surrounded by 2 iodine. Okay, if you count the electrons, you will find them 16 electron. Now, let us answer the question: what is the electron pair geometry? We have here 2 bonds around it, which makes it linear. No lone pair, which makes it linear. What about the polarity? This is partially negative with respect to beryllium. Linear, so they cancel each other, so it is non-polar. And when we have 2 electron clouds around it, so the type of hybridization is sp hybridization. So we solve these examples of molecular geometry. We can solve more. Let me solve with you still. Br F4 minus. Br belongs to group 7, so 7 electrons in the valency. Fluorine, similar, 7 electrons, so the total valence electron 7 plus 4 times 7 plus 1, because here -1, it means adding electron. So we have 4 by 7, 28, plus 1, 29, plus 7, sum up to 36 electron. We have bromine and surrounded by for fluorine, so for fluorine, each fluorine carries 6 electrons. 6 by 4, 24, 25, 26, 27, 28, 29, 30, 31, 32, and 2 lone pair, 33, 34, 34, 5, 36. So here, what will be the electron geometry? We have 6 electron clouds around it, so it is octahedral. Octahedral. Okay. And now, what is the molecular shape? It will be distorted due to the presence of 2 lone pair, so it will be square planar. Square planar. Now, is it hybridized? Before hybridization, is it polar or non-polar? Let me redraw it, this one, in order to see polarities. So square planar, which means like this, we have BR, F, 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 and this one like this. Okay, and all of it minus. Fluorine is more electronegative than bromine, so this is the arrows. Okay, this arrow cancel this one. No net dipole, so it will be non-polar. Definitely here we have the lone pair, non-polar. Now the type of hybridization, since we have 1, 2, 3, 4, 5, 6 valence electron clouds around it, so it has D2